we are. This is Hacking Mobile Devices. As far as other events, we are going to have okay, now we're up to Thanksgiving, so there's, of course, nothing happening here on Saturday. The campus will be closed through Thanksgiving. But a week from Saturday comes the CCDC Invitational. So I highly recommend everybody to come to this. It's good for you. It's available free to everybody, worth extra credit, and you can even just come watch, or you can join in trying to defend a network as Caitlin hacks you. Caitlin is a graduate of this program, and she is incredibly lethal. And
9 to 5?
9 to 5, yeah. But you can come for part of that time if you like. You don't need to come for all of it. Yep. So check it out, the one on December 6th and one on January 24. And then we'll have the actual qualifier on February 7th. That's where you actually have to be officially on the team and probably a full-time student and restrictions like that. But the invitationals have no rules, the way I like it. So any student can show up and participate or watch. Nobody cares. That's the way it ought to be, in my opinion. All right, so now this is 128. We're coming to the end of the class. We're down to, there's 2 more lectures, and that's it. The last class is on December 10th, and I'm not going to present any new material. I'll just answer questions. But we're going to talk about attacking iOS, and I have a whole bunch of iOS projects now, which I haven't said that we haven't been in this course now, but I got a bunch of them working, so I'll show it to you. We can do some projects without jailbreaking the iPhones. Jailbreaking the iPhone is necessary to do really in-depth stuff in projects, but we can do quite a bit with dynamic analysis on non-jailbroken iPhones. So that's what we'll do. Anyway, let's start with the slides here. So, which are in fact, for once, exactly on target for what I'm going to demonstrate in the projects. So, about transport security, insecure storage, and analyzing iOS applications with binary. And we're going to, all right, so then we have some more stuff next time. But all right, so you're going to attack an iPhone from the network, of course. So if you have any kind of way that data could come in from the outside, like email or PDF files you download or other signals, all that could attack the apps on the phone. You could also have physical access to the phone and connect with a cable, or you could have interactive access to the phone, which means you managed to get a malicious app on the phone, and now you can attack other apps from the app. Yeah. Okay. So transport security, we've talked about. This is real important. If you have transmitting unencrypted data into the phone, that's never safe. Even if you're just transporting something fixed and boring like an image, an attacker in the middle could add scripts to that and run scripts in your browser. So you basically are handing over code execution to some extent to anybody with control of the network, and therefore nobody should be using HTTP for anything anymore. And I was amazed to discover, as I audited about 1,000 iOS apps in the last week, and I found about 23, 24 of them that are vulnerable, and a bunch of them are using plain text transmission, which I thought Apple had outlawed like 5 years ago. They made a big deal of adding a new software foundation that was going to force everybody to use encryption, and they said if you turn it off, that will trigger a review by our team, and we'll probably reject your app, and apparently that is not true. There's a bunch of apps still using plain text transmission, which caught me by surprise. Anyway, so for clear text, you can just look at the traffic with Wireshark. You can also go through Burp, which is what we're going to do, because then you can do more than clear text. And say, so there are 3 implementations of TLS to load things. There's a URL loading system, like Carbon Framework, and the Secure Transport API. And so the URL loading system has high-level methods to make an URL connection and download things, and this is the most common one people use. The Carbon Framework is more granular and lets you control the network requests in more detail. And when I see technical error messages, it seems to refer to this CF network class a lot, the ones where I actually get error messages from breaking SSL. And then Secure Transport API is the low-level API with the greatest control. This is analogous to the native API in Windows. Very few developers would use it directly. You'd use one of those high-level frameworks. So the point is you have to have certificate validation. The whole point of TLS is that you connect to a server like Gmail. It sends you a certificate, which is a digital ID card. You do not believe that certificate, and you contact the trusted authority that issued it. The authority must be a known trusted authority built in your browser. There's about 100 of them. And then you contact that authority and say, is this thing genuine? And only after they agree that it's genuine do you believe it and use that key. This is why encryption works. In order to encrypt data you're sending someone, you have to have a key. So you have to get the right key to send it to them and not a forged key sent by an attacker. And that's the system. So if you actually do the validation, this is a very strong system. But I found an interesting, a good article from years back saying that 3% of Android apps and 7% of iPhone apps fail to validate their certificate. And that matches my experience. It's not that hard to find ones in either system that fail to validate the certificate. If you audit 50 or 100 apps, you'll find them. So they have to be signed by a trusted certificate authority. And that's the point. Now, you can allow self-signed certificates by customizing the method, and this is apparently what 3 or 7% of developers do. They turn off the authentication. I would imagine, some of them, I imagine, do it in order to test the app and forget to turn it off in production. Another thing, I've actually had discussions with 2 or 3 app developers when I report this, and they have made it clear that they do not understand what TLS is at all. They don't understand how it works. They don't know what certificate validation is. Some of them don't even know what encryption is. And so they just make the app work, like I'm saying, just like people with unprotected APIs. They make the app work, and they say, my job is done, the app works. One guy even said, I turned on the HTTPS, and then a bunch of people were getting like blank pages because their browser couldn't handle the connection. So now I turned off the validation, and it's all, my app works better. And, that's probably true. You get more availability by not bothering with the encryption. And if you don't understand the consequences, that seems like a good decision. So you can allow self-signed certificates by setting a constant. And the Secure Transport API also has a way to turn off the validation if you want. Now, you can add extra validation to your app if you want to, where it actually checks the certificate with certificate pinning, where it independently checks something like the company the certificate came from to make sure it's the expected one. And that's even more secure, and that's what Google Play does. But, I don't really think it matters whether anybody does that. I would be glad if they would actually just use the default SSL verification. Anyway, so here's the problems. You can have self-signed certificates, which are not in fact signed by any authority at all. You can have expired certificates. You can have host names that don't match, expired root certificates, or just ones that allow any root certificate. Good evening, Gary. So we're going to do it with dynamic testing. Just like we did with Android, we can do that with iOS, and I'll show it to you later in the project. Here's another flaw that was kind of amusing from 2014. Apple had an update, and this showed that something was horribly wrong with SSL. This was called GoToFail. They're using GoTo, which, by the way, is not considered a good coding practice. But anyway, this is one. So they have this series of things that can be wrong with your certificate, and then they have 2 GoToFails in a row. So what happens is, if this error is true, it goes to fail, and otherwise it always goes to fail. It never gets down here at all. So it always accepts every certificate, is what this means. Because the repetition of this line means it doesn't actually do the tests, it just always answers that the certificate is okay. And again, that was resisted for a while. Like I'm saying, if you fail to validate certificates, nobody will complain. Authorized users continue to get service. It just means that a certain relatively difficult attack will succeed, and nobody will notice that. So you can have an operating system, IE3 did this. A bunch of operating system browsers and everything can fail to validate the certificate and be that way for years. Nobody will notice, nobody will care. It seems to work. The fact that it has a hole, it's just like your router has a default password. Well, you don't notice, you don't care. Your router works. Only until it gets infected by somebody, there's no apparent harm. So anyway, all right. So there's other possible SSL errors, which you can turn on. But anyway, all right. There's various protocol versions. If anybody's actually using SSL anymore, version 2 and version 3, those are vulnerable. I haven't seen anybody do that. And there's a bunch of settings for the various versions where you allow these old versions of things, which I don't think anybody much would want to in America anyway. Perhaps in other countries where people are using really old stuff like MS-DOS or Windows 95, you might want to allow that really old stuff. You can turn them on if you want in principle, but I haven't noticed that, although I haven't looked for that. I guess I wouldn't know. When you do a TLS connection, when you open a website, it does a SYN-ACK to open transport on port 443 on the server. And then your browser sends a client hello, and your browser says, I speak these encryption algorithms. And that depends on how old your browser is. If your browser was IE3 or something, then it would have a much shorter list and they would all be old and vulnerable. This is a more modern browser like Chrome, so it has 17 ones and they're mostly pretty good. But you would say, here's the various encryptions I can support, and you're asking the server, do you talk any of these? And the server then decides if any of these are good enough. Or it can say, I'm not going to talk to you because your browser is too old, and even your best algorithm is not good enough for my standards. They usually don't do that. Most servers support pretty old things in order to serve all the clients. But that's how it works. The developer may specify an insecure suite. So you could change yours so it only offers one of the old vulnerable ones, and then see if the server will go for it. And if it will, then of course you can get in. You can do that in your code. You can say only offer particular suites. Now, if you want to intercept encrypted communications, as we said, you can use burp or other proxies to sit in the middle. It'll automatically generate a fake certificate for every website signed by Portswigger. It's perfectly cryptographically valid, but Portswigger is not a trusted authority. So every app that is correctly implementing TLS should pop up an error message and complain or refuse to connect because it's not a trusted TLS certificate, unless you install the burp certificate on the phone. If you do that, then the app should all operate normally, unless they have certificate pinning, which means they will not settle even for the operating system saying it's a good TLS connection. They'll have a second test to see if the certificate actually came from the expected source, and they will see Portswigger is not the expected source. So if you have an app like Google Play that has certificate pinning, then even installing the burp certificate will not let you view it. And so you have to use various techniques to kill that pinning. And the one we did in Android was modify the code and rebuild the app without the pinning code. You can also do it with Frida if you can get Frida to work. And as we've seen, getting Frida to work even on Android is pretty painful. It's much worse getting Frida to work on iOS. And what developers do is they have a special device they've jailbroken and a special Mac they use, and they get them both working, and they sort of leave them working, and tune them up. These things are difficult enough to do that you have special setups and use them. It's not something a normal student can set up and get working. All right, so then there's insecure storage. Now, I've quit reporting insecure storage on the iPhone as a vulnerability because I think the operating system makes it very hard to steal the data. In fact, it's very hard to audit now. You can't even back up the app or the data from an iPhone without jailbreaking it, and jailbreaking it is very difficult. So anyway, it is true that there is a secure keychain where you should be putting the secrets, and developers might be just putting it in the local storage of that app, and that's a failure to perform a best practice. But I'm not sure it really counts as a significant vulnerability anymore because there is no conceivable attack scenario where anybody could steal that data from a non-jailbroken iPhone, as far as I can tell. So it's not the best thing to do, but I'm not sure it's worth reporting. Anyway, that's the point. Now, if the cops impound your phone and then get in there with something like Celebrite, then they can steal that data, which is true. If people are able to bypass the login somehow, bypass the touch center, or if you have default credentials on a jailbroken phone or there is no passcode, then people can get in. But I think the number of people with that problem is now very small. I think most people have a passcode on their phone, and the stored data is probably not going to be exposed. And that's what I say in all this layers of encryption. The stored data is behind 2 or 3 layers of encryption. It is really not easy to steal. Even if you get to install a malicious app on the phone, it's still not easy for that app to steal data from another app. So, like I say, this flaw, I think, is less of a worry on iPhone than Android. And so there are a lot of protection classes. We talked about it. You can have unencrypted data. That would be bad if you actually have that anywhere. But pretty much everything's encrypted with one of these things like complete until first authentication. So you can try to back up the data to audit for this. And I tried this. I installed a tool that would back up the data, and it gets almost nothing anymore. You used to be able to back up a lot of the data from apps years ago. Now all you get is the data specifically marked to be shared. So it's very hard to get a copy of what's on the phone, even if you have the login. So keychain is where you should have things. There is a keychain. That's where you're supposed to put secrets in Mac OS or iOS, and for that matter, Android, and it's well protected. All right, so if you look for stored data that doesn't get backed up, like I say, then you'd have to use, there used to be a tool called Snoop It that would let you see what's on the phone, but it's gone. Now you pretty much, the only way to do it is jailbreak your phone, which is not easy anymore. And then you have complete operate. Then you can analyze the operating system and all the apps in their binary form. So if you get an old jailbroken phone, which is the only kind of jailbroken phone that you can get anymore, unless I think you pay thousands to get an open phone, then you can download the binary. And I used to have a project for this. It's not in the current version of this class because it's pretty badly out of date. But you have a jailbroken phone, you can pull the data off the phone, just like we did with Android, and get a copy of the binary that runs on the phone, and then you can disassemble it with Hopper. Probably Ghidra would work too, and then you can get assembly code to read. And if you use Ghidra, you can probably get that down to like C++, make it somewhat more readable. And so then you can find the code that does things like jailbreak detection. Here's the message, this device is jailbroken. So this is where you'd be able to find the stuff to comment out to get it to not do that. So in principle, you could do that. And we're going to do it next semester in the malware analysis class and exploit development class. We'll do this kind of binary modification, but not for iOS apps, for Windows apps and Linux apps. There we can do it. The iPhone, it's too difficult to get in. Unless you have a jailbroken iPhone, you really can't have any of that fun. And so here it is, decompiled down to somewhat readable C++ or Java or something. And you see here's the thing that's going to print this message. This device is jailbroken. So commenting out some of this would be how you stop the jailbreak detection like we did on Android. Anyway, let's take a look at a Kahoot. Good. And this is 3A. That's right. He loves them at the moment. That's fine. All right, let me. It sounds like they've got changed the music. They do this on holidays. Is it not Halloween? What the heck is it? Thanksgiving. I don't know what music to put for Thanksgiving. This sounds like Halloween music. Anyway, what's that? Oh yeah, Yuri. Yeah. Well, he is a student here, but he's not physically at CCSF. Yeah. 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 Oh, good. Then you must have had an A. I filled in the A's for people who already have enough points for an A.
Oh, it's preemptive. You know the class is not over yet.
Yeah, but the point is you don't have to do it anymore, and if you do, you won't lose your A. There's no way to lose points. Okay. So I figured I'd fill it in. A lot of people, want to focus on another class after they have enough for an A, and that's okay if you want to do that. Yep, but that's...
I'm doing this for 1.5.
Yeah, I mean... Yep.
You guys be awesome? Yeah.
Good.
So the final exam is the 10th if we do not have an A.
Yep, it's optional. You don't need to take it. It won't affect your grade.
It's on the 10th?
What's that?
What day is it?
It goes on for the whole week and finals week. So,
Wednesday night.
yeah, right here, 12/12 to 12/19. Yep. Take it any time during that time period.
It's online.
Yeah, it's online. You can go, yeah. Good. Yeah, and a lot of people don't take it. If you've done some extra credit projects, you don't need to, and that's fine with me.
Can you find out what our actual number is?
Yeah, your total score is there. Yeah, total score is there in Canvas if you want to see it, yeah.
Canvas, CNIT 128.
Yep.
Canvas, on
Yeah, the one I'm using, yeah. All right, good. These are good questions. There are always questions about grading this time of year. Yep, if you have an A, you can work on all these. When the class is over, it'll go to my old classes page and you can keep working on it and referring to it, and a lot of people do. So it'll just stay up there apparently forever. Got everything for the last 20 years up there. And my hosting provider changed the rules to unlimited storage. I say, well, fine. If you're going to be like that, I'll just leave it up forever. I appreciate that. All right, so here, let's try this Kahoot.
Stuff doesn't go away.
All right, so which scenario might use malware in the App Store? That's called interactive, where you have basically code execution on the device, and you can use that app to attack other apps. I'm not aware of this happening on iPhones, but it happens on Android. Anyway. All right, which implementation is the most commonly used to make secure connections?
To make secure web.
network connections. Yeah, the URL loading, by the way, this is exactly analogous to Windows. We'll do it next semester in the malware analysis class, but there is a high-level library that just connects to a site and downloads a file, which is what real developers use. The native API, where you control the packets one by one, is not used by normal developers. You'd only use that basically if you're writing malware, because it's a whole lot of extra work. Normal people just want to connect to a normal site, and you let the operating system do it all for you automatically. That's what a normal developer would use. All right, so you install Burp certificate, but you still can't intercept network traffic. So what would cause that? Yeah, that's certificate pinning. The app itself is doing a second test, more picky than the operating system on the certificate, and it detects that it's not the right certificate. All right, how do you get user data from a stolen, locked phone? All right, you have to be able to log in. Check Rain will not get you the user data. It'll jailbreak the phone, but you won't get the user data. They designed it that way because the people that developed it are jailbreakers and they do not want to help criminals. You can't try puny passcodes manually or it'll erase all the data. If you can bypass the touch sensor and log in, then it'll work. If you can somehow make a fake copy of the fingerprint or something. But that's what you have to do. You have to log in like the user or you're not going to get that data. So get their PIN, seal it with a camera or something. If you can't log in, you can't get it. And this was at the FBI's request. When iPhones first came out, people would wear these special headphones with colored lanyards, and they would get stolen all the time. There was number one theft. Wearing that thing would make it obvious you had one. It was worth several $100. They were stealing them everywhere. It was the number one theft item in America. And the FBI asked Apple, will you please make it so the iPhone is like a credit card? So when you steal it, it gets canceled, and the bad guy can't use it to cut down on the theft. So that's what they did. They made this system where if it's not logged in, you really can't get in, you really can't wipe it and resell it, it's really hard to do. And then, a couple of years later, FBI came to them and said, hey, we found this iPhone for a terrorist, let us in. And Apple said, I hate you so much. You made me lock everybody out, now you want to get in.
What's the colored lanyard?
Yeah, well, the colored lanyards were the earphones they had in the first, and you would wear these things and listen to music on your iPhone, and that would just tell everybody around you that you had this high-value item to steal, and you're not paying attention because you're listening to music, so they were just getting stolen everywhere. And that's when the FBI said, cancel it like a credit card, so a stolen iPhone is no good, so that's what Apple did. And that's this modern system. If you can't log in and disconnect that phone from now what they call, Find My Phone and iCloud, you really can't do much with it, and that's by design, to make it less valuable to steal phones. All right. All right, so let me